Assalamu alaikum everyone. I am Shruti Shahatoni. Today I will describe about four-wheel robot project. In this project, I mainly describe the robot body shape part. In this robot section, here we can see in this children section a lot of drop downs, which is mainly describe our these different parts of this robot. Here mainly we use three distance sensor left, distance sensor right, and distance sensor mid. These three sensors will help me to follow our path specifically. We can also our see our distance sensor ray from here, from this the show distance sensor rays, which will help our distance sensor show it correctly or not. Then this there are four hinge joint. These four hinge joint mainly are four wheels of this robot. The Here it's in this robot, the his position meaning translation and the rotation values are different, but size scaling are same. And for these wheels we mainly use cylindrical shape, and in this body shape we use a box shape here, and the rest of the part will described by my other group members. Thank you everyone.
Hello, I am Shurujit Roy. I am going to describe infrared sensor and how does it work. Infrared sensor essentially have a light emitter and a detector. A light emitter throws light. This light is observed and reflected back. Depending on the type of material and color, different object will emit light differently, and the detector in the infrared sensor will detect the reflected light back. Based on the value of light and that was reflected back, we can detect different objects, and then we use this information to differentiate between our floor and our line. Thank you.
Hello everyone, I'm Jannatul Firdaus Khanlisa and I'm going to show how we create a track for our robot. So first of all, we need to search Tinkercad in Google. Then we need to click in this link. Here I have already created an account, so I just need to click on create new design. Now I need to choose the scribble. So according to the rules, we need to use 3 or 4 turns. So we just created lines like this, then done. Then choose the height as 0.1 and uh, choose the color as black. Then we need to export it as a .obj file. So here as we see that this file is in zip, so we need to extract the file to run it. After that we open our vboard file project file, and then choose the file. Here we choose the import 3D model, then click on next. Then we have choose our file which we have created and download from Tinkercad. After opening this file, we can show this line here like this. This is how our robot is moving from the track. So here in SolidBird, we have set the values in translations, then rotation and scales to create our path or track for our robot. So this is how we made. Thank you so much.
I am our host Angelani. Today I am going to represent the recording part of our project, for which our robot is acting like a line follower robot. So at first we import the robot, then we give an instance of this robot class. Here we write a code which is represented the connection between our robot wheels and our code. So the device name need to be same what we earlier declared in this making section. And this part we are initialize the sensor, and this device name need to be same whatever we declared earlier. And this portion of the code give us the value which we will able to see in this console part by this printing command. And in for this part of the code, we are processing sensor data but the value we need to the value 300 is 300. We need to calibrate it from the sensor data. It depends on the reading of the sensor. As we can see, the console data when the middle sensor is active, it given us a reading of around 390. That's why we make the threshold value 300. If the sensor is not in the line, when it gives the value less than 300. But if it is on the line, it gives the value more than 300. So in our first condition, we can see if the left sensor and the right sensor value is less than 300 and the mid sensor value more than 300, all the wheel of the robot go max speed. And the rest condition are same with slight changes in scope. So from this condition of robot, we understand when to go, when our robot is going straight, left, or and right. So now we can see this simulation part. So in the simulation part, during the left arm, the left and the middle sensor will give a high value, where the right sensor give a low reading. This causes left motor to stop temporarily, and right motor speed up temporarily. This is how robot is done is its left turn. On the other hand, when the robot makes its right turn, the right sensor and the mid sensor giving a high value, and the left sensor gives a low value. This causes right motors to stop temporarily and the left motor speed up. This is how our robot make its right turns. So this is how our robot is working like a line follower robot. Thank you for listening.